Okay, so we're on video now.
Alrighty.
All right. Okay, so tonight we're going to be talking about the second half of printed circuit board design. Okay, on Tuesday night we talked about the first half, and that was creating a schematic diagram. So when you were all done with Tuesday night, you should have had a schematic diagram that looks something like this. And I hope you guys saved that, because we're going to be using that as the foundation for tonight's lab. Okay? So let's review a little bit about the schematic layout process, and then we'll talk more about the circuit board layout tonight. Okay? So what we did is we had a circuit in mind, and then we started laying it out in our schematic. Normally, you would do some design ahead of time. You might do some, sketches on a piece of paper, work things out in your head. You'd probably do some breadboarding to do a prototype of your circuit, make sure it works. And then once you were sure that you had everything correct, you might start putting the circuit into the schematic layout program. I gave you a circuit to use on Tuesday, so you guys had a little bit of a head start there. But once you have the circuit that you want to create, you go through a couple of steps to lay it out in the schematic program. So first of all, we selected all of our components from this list on the left. So we chose diodes, resistors, a chip here. This list has a wide variety of components. It has many different sizes of resistors and capacitors, diodes, all the standard stuff. It has many different chips from many different manufacturers. So there's a lot of things to work with. But sometimes the component that you need is not in that list, so you have to create it for yourself. I did that with two of the components that you guys used. I did that with this power supply and this switch. Okay, those were not available in your list of components, so I created those for you. We're not going to talk about the process for actually creating your own components in this class, but just be aware that that is something that you can do if you have to make your own board at some point. Okay? And it's not that hard to do. It just takes a little bit more time than we have in this class. So we started our design process by putting the components down on the board, and then the next thing that we did is that we connected all of the components in the way that we wanted. So we drew lines to represent wires between these components, and we made the connections. Now, sometimes the lines would have been confusing. For instance, having a wire from this point over to this point would have crossed at least one wire and maybe more. And so sometimes you don't want to draw the wire directly from one point to another. In those cases, you can make a connection by using a name, right? In this case, this terminal of the chip was called the output voltage, so we labeled this wire V out. And we also labeled this wire up here V out. And by calling them the same thing, exactly the same name with the same capitalization and everything else, the computer recognizes that we want to connect those 2 points. So we can make that connection without actually drawing the wire on the sheet. And this is standard practice in large schematic diagrams. You will see one label used in several places on the schematic, and that will indicate that all of those places are connected to each other. This is especially important when you have very large schematics that span 2 or more pages, because you cannot draw a line from one page to the next. So you have to use these labels to indicate what part is connected to which other part. Okay? Now when you put the components down on the board, or on the layout here, they did not come with values pre-listed, right? So that was another step that we had to do. We had to add the values to these components. So you could right-click on the component and select Properties, and then type in the value that you wanted to use. Okay? So we were able to label the values on these various components. Okay? And these labels that we put on the components here in our diagram will also show up in our actual final printed circuit board. So these labels are very important because this is how people will know which resistor to put in which place, which capacitor goes where. All right? So they're important when we're making the schematic so that we know that our schematic is going to work right, and then they're important because they transfer over to the printed circuit board as well. Okay? So the goal of this whole exercise is to learn a little bit about creating printed circuit boards by making a design for a fun printed circuit board in some kind of shape that is interesting. But you'll notice that on this diagram we did not lay out the LEDs in any particularly interesting shape. We just sort of put them end to end in series. So that's because the purpose of this schematic is just to make the electrical connections that we need. It's not to indicate where the components are going to go on the final board. The layout and design of the board itself is what we're going to talk about tonight. So any questions about the schematic stuff that we did last time? Okay, cool. Then let's talk a little bit more about the process of creating a design for our actual board. So we've got this nice schematic. We want to actually we want to take all of this information and use that as the basis for our printed circuit board. So the way that we do that is we open up the schematic here. We go to File, and then let's see. We say Convert to PCB, okay? Or Control B works as well. So we click on that. And now that opens this other portion of dip trace. So this new portion that's opening up is the schematic, or the printed circuit board layout portion. Okay. So remember when we looked at the launcher, we launched the schematic capture portion at first. Now this new portion is opening up automatically. That's the PCB layout portion, okay? So we can say use schematic rules, that's fine. That's fine. And this brings up the schematic layout portion of our, the printed circuit board layout portion. Now I accidentally chose the black background. I don't like the black background as much, so I'm going to change that. So I'm going to go to View, and then Colors, and I'm going to, right now you can see it says black background. I'm going to change that to white background, okay? So if you chose the wrong one and you don't like it, you can always switch it around. So let's take a look at what we have here to start out with. What we have is, you'll notice that we've got one footprint for each of the components that we had placed on our original schematic. Okay? So the PCB layout program took all of the information from our schematic and brought it over here. It knows which components we had, so it made representations of each of our components. And it's also got these blue lines going from various pins on our components to other components. These are called rat lines, and these are showing us which connections need to be made. These came from the schematic that we created, okay? So when we made a connection in the schematic, the program remembered it, and now it's drawing these rat lines. These are indicating connections that must be made but have not yet been made on our printed circuit board. So by the time we're done with this whole thing, we will need to actually tell the computer exactly how to connect all of these different components to everywhere that they need to go. Okay? So we're going to get to that in a minute. But before we do that, what we want to do is we want to lay out the components in a way that kind of makes sense, right? So right now you can see that the diodes are still over sort of in a rectangle here. We've got these rat lines going all over the place. They're crossing over each other. So you want to lay the components out in some logical way. So that means probably if there's a lot of connections between one component and another, you might want to put those two components near each other. You might want to try and lay out the components so that there's not a lot of these rat lines crossing each other, because that would make it easier to make those connections eventually. In our case, we want to lay out these diodes in an interesting pattern, right? Something, I mean, that's the purpose of this exercise, right, is to create some fun pattern with our diodes. So we want to move those around and make some pattern that is interesting to us. So that's going to be our goal, okay? We're going to start by moving our diodes around into the general shape that we want. And then we're going to move the rest of the components around so that they fit in with the diodes. Once we do that, we will start to make the connections, actually tell the computer how to move wires, how to route wires from one component to the next. Once we've done the wires, we'll draw the outline of our board and show the computer how we want our board to actually look, okay? And then finally, when we've got the board all set and all of our components there, we can talk about adding some decorations. We can put extra text on there if we want, you know, a little message. We can do stuff like that. And then optionally, at the end, if you guys like the way that your board turned out and you want to actually get it printed, I can show you how to export your design into a file format that you can send to circuit board manufacturers. Okay? So that's going to be what we're going to work on tonight. Okay? Any questions before we get going? All right. Cool. So let's start by putting the diodes into some sort of pattern that is, you know, that we're looking for. Okay. So to move a component, you just click on the component and drag it over to where you want. I'm not going to be too fancy here. I'm going to try and make sort of a star pattern, I guess. So you can move the diodes around wherever you want. So it's pretty easy to just drag them and drop them where you want, okay? So my star pattern is not looking very star-like at this moment. But we'll do something like that. It would be, what, an 8-pointed star? Sure. Alright, so you can move the components around there. Now, some of these components look sort of all twisted up. Like this diode at the bottom has its, you know, the left terminal is connecting to the diode on its right, and the right terminal is connecting to the diode on its left. So I want to make life a little bit easier for this one, so I'm going to click on it, and I'm going to hit the R key on my keyboard, and that rotates the diode around. When I do that, you can see these wires untwist, and they point more in the direction where they should be going. So you can do that. All right, so I've untwisted those diodes a little bit. Now, so this is the general pattern that I want to have for my outline here, or for my diodes. So now I'm going to start working on the actual components. So again, right now these components are in sort of a jumble. No real rhyme or reason to how they're set up. So I'm going to start looking at where all the components are connected, what other things they're connected to, and I'm going to try and move components next to each other that look like they should be next to each other to sort of minimize the number of rat lines that are crossing each other. There's no magic formula for this. You just sort of move it around until it looks like it's going to be not too hard to actually make the wires go where they're supposed to go. Okay, so you can rotate components around if you have to. You can just rotate them and try and get them to be in a place where not too many lines are crossing. Okay, so you can keep doing this for a while. I'm going to call it good right here, just for the sake of time. But you can keep going and trying to make this as efficient as possible. So after you have arranged your components, it's time to start connecting components together. So this is the part where we actually tell the computer how we're going to make connections from one component to the next. Okay. So to do that, I'm going to use this tool at the top that says Route Manual. Okay, so this allows me to place a line or a wire on my board. Okay, so I'm going to choose that, and there's two layers where you can place the route. You can place it on the top of the board or on the bottom of the board. Okay, this is called a two-layer board, so it has copper traces on the top and the bottom of the board. So you can choose to put your trace either on the top or the bottom. Right now, I have selected top, and you see there's a little 1 next to it, so if I want to select that, I just hit the number 1 on the keyboard. I could also select bottom. So there's a 2 next to that, so I can just hit the 2 on the keyboard. So if I hit 1, I go back to the top. If I hit 2, I go back to the bottom. So you can switch between those. So that brings me to another point, which is that for our boards, we want the LEDs to be facing you. And we want most of the other components to be facing away, right? Your design is primarily going to be flashing LEDs. So when somebody looks at this, you want them to see the LEDs. You probably don't want them to be focusing on the components, right? So it's probably a good idea to put the LEDs on the top side of the board and the other components on the bottom side of the board. Okay? So that way everybody sees the LEDs and the other stuff is hidden. It's in the back. So when you create the schematic, everything is on the top of the board by default. But you can move it, you can move components to the bottom. So in order to do that, you right click on the component that you're interested in, and you say change side. Okay? So right click and change side. Now when I do that, you'll notice that the component appears kind of grayed out, and also the text on this component is mirrored, right? That's because it flipped to the other side. So when it flips to the other side, the text would appear mirrored because it would be on the back of your board. Okay? So I'm going to do this for all the components, and you probably want to do this before you start laying them out. I should have told you about this earlier. You want to do them before you lay out all your components, because when you flip them around, oftentimes it changes the orientation of the pins. Okay, so so you probably want to put them on the opposite side before you start moving everything around. Now, when you move them to the bottom of the board, they become grayed out, like I said, and it's no longer possible to grab them and drag them. That's because right now we're working on the top of the board. If we want to start moving these components that are on the bottom, we hit the number 2 on the keyboard, or we come up here and we switch to the bottom. And now you'll notice that these components on the bottom are clearly visible, and the components on the top get grayed out. So when we're working on the bottom side of the board, we can manipulate the components that are on the bottom, and we cannot do that with the components on the top of the board. Okay? So, so you can do this. You can move your parts around just like we did before. This battery holder that I have is supposed to have a battery that sticks out at 90 degrees away from your part. Okay? So my thought was that you could use this battery as sort of a stand, right? You could lean the part on this battery. So that's something to keep in mind when you're doing your design. So again, you just do your best to get the components laid out in such a way that there's not too many rat lines crossing, and then you call it good. All right, so now it's time to actually start adding the wiring connections from one component to another. So what you can do is you click on this route manual, and then you click on one terminal from one of the parts, and then you figure out where it has to connect to. You look at that rat line. Okay, so I'm going to click on the top terminal of this capacitor, C2, and then I see that there's this rat line going to C1. So the black line, which is extending from my cursor, is where the wiring is. Okay, this blue rat line, which is following me around, shows me where my wire has to go. Okay, so I'm going to just take a straight line from my capacitor C2 over to capacitor C1. I'm going to click on this pad of C1, and then I've made my first wiring connection on the board. Okay, so you'll notice that there's no longer a rat line between that terminal of C2 and that terminal of C1. That's been replaced by this connection that I made, this actual trace. So every time you add in a connection, you get rid of one rat line. So you have to go through and do this for all of the rat lines. Now there's one thing that I think makes the diagram a little bit easier to understand. That has to do with this layers dialog box in the top right-hand corner of your screen. This shows you all of the layers of your board and all the colors which represent those layers. So you'll notice right now the top and the bottom are both black. Okay, so these are, if you put traces on the top or the bottom, they both show up as black. Well, I like to distinguish between the top and the bottom. I like to know which one is which. So you can change that color for one of them. So if you click on the color here, you can pick a different color for the top or the bottom. I'm going to choose orange for the bottom. And now you'll notice that my wire that I just made shows up orange. So that shows you that that wire is on the bottom of the board. Okay? So I've made that connection there. So you can make other connections as well. You can start doing that. I'll make a connection there. That one's orange as well. If I want to make a connection on the top of the board, it's fairly easy to do that. You just go up here and select top, or you hit the number 1 on the keyboard, and then you do the same procedure. You click on the terminal that you want, you click the terminal to connect it to, and it shows up. Now you'll notice that this connection is made in black because it's on the top of the board. So my other connections are in orange on the bottom of the board. This connection is in black on the top. Okay? Sometimes it's not possible to make your entire run on the top of the board or on the bottom of the board. Sometimes you have to switch over from the top to the bottom halfway through. Okay? And it's possible to do that. What happens is that if you want to do that, the circuit board has a little hole that gets drilled through from the top to the bottom and plated with metal. And that makes a connection from your trace on the top to the trace on the bottom. And this little hole, this plated hole, is called a via, V-I-A. And so it's possible for circuit boards to have those. Many circuit boards do. And it's pretty easy to create them in this program. The way that you do that is that you just start making a connection on one side of the board, and then when you're partway through, you switch sides, and then you keep on going. So, for instance, I'm going to make this connection from the battery to my resistor. So I'm going to click on the terminal of my battery. I'm going to start moving towards the resistor. I'm going to click there, and now I'm going to switch from the top to the bottom. Right now you can see I'm on the top up here, number 1. So I'm just going to push number 2 on my keyboard, and now I've switched to the bottom. And I'm going to continue going and make the connection there. So you can see that what I did here is I started off on the top. So the first part of my connection is shown in black, and then there's this little circle that represents the via, where the trace switches from the top to the bottom, and then the rest of my connection is drawn in orange to show that that's on the bottom of the board. Okay, so you can switch from the top to the bottom or vice versa in the middle of a run. Okay. Now you probably won't have to do that on this type of circuit board because you don't have that many connections, but I just wanted to show you that it is possible. Okay. All right. So any questions about that so far? Okay, so you would continue on with that procedure and make all of the connections that you want to make, and you keep going until all of the rat lines are gone, okay? And then once you've got your connections, you want to draw the outline of your board. So the way that we do that is we come up here to the tools on the top of our program, and we find the Place Board Outline tool. Okay? So once you find that, you just start drawing points to create the outline of your board. So this program is not especially friendly for creating really fancy board outlines. Okay, you can create board outlines with straight edges, no problem. When you start getting into curves, this has more trouble. Okay, so if you wanted to create a board outline that has lots of curves in it, that is possible, but what I would recommend is you would use some other type of software like AutoCAD to create the shape of your board first, and then you export that as a DXF file, and you can import it into this program as a DXF file. Okay, so if you want to make a board that has just straight edges and straight corners, then this works just fine. If you want to create a rectangle that has rounded corners, this can actually do that for you too, but anything much beyond that is going to be hard in this program. Okay. Once you're all done creating your outline, you hit the Enter key, and that will finish making the outline for you. Okay. So that's how you create a board outline. Now, after you've gotten the outline, you can add some text and things, and you can make your a message or some note about the version of this board or whatever you want. So the way that you do that is you click on this text tool, and then you have to choose which layer this is going to go onto. So you want to choose either the top silk layer or the bottom silk layer. These are the silk screens. These are the white writing and markings that are shown on your board. So if you want to put extra text on your board, you want to choose the top silk layer or the bottom silk layer. Okay. So in this case, I'll choose the top silk layer, and I will put a message here. I'll just say, Happy New Year. And then you hit enter when you're done. And if you look at the top layer now, or the top of the board, you can see that text. Okay. So so that's how you put the text on your board. Now you'll notice that we have these components, but we don't have the values shown up on the components, right? We spent all that time creating the values in our schematic, but they're not showing up in our printed circuit board. So I think that what we have to do is we have to change a setting to make those show up. So let's see. So if you go to View and then Component Markings, and then you choose Additional, you should choose the value. Okay, so this makes the value show up on all of your components. Okay, so that way people who are assembling this board know which resistor is supposed to go in which place, right? Which capacitor size they need to put into your board. So that's an important thing to do. So that's pretty much the process that you guys are going to go through in order to create your own printed circuit boards. Any questions about that? Okay. So let me show you one more thing, and that's the last step. That's exporting the files if you want to get them actually made. The way you do that is you go File, Export, and then you choose Gerber. Gerber is the type of file that is standard in the industry for the layout of printed circuit boards. And we talk about Gerber files. What happens is that the program actually creates one file for each layer of your board that you have. So there will be one file that is only the silk screen on the top layer. There will be one file which is the board outline. There will be one file which shows all of the copper on the top layer, and so on. So when you export this, you'll actually be creating several different files, probably 6 or 8 different files. Each circuit board manufacturer has their own standard for the file names that they want, and exactly which of the layers they need to see. So you can customize the way that these files get exported by clicking on the Files dialog here. Okay? And then you can choose which layers to export and also what to name each layer. So you can do that, and then when you're all done, you click on Export All, and that will export all of the files. The one thing that this does not export is the file which describes where all of the holes go in your board. So you need to create a separate file for that. To do that, you would come up here, you go Export NC Drill. Okay, so that specifies where all of the little holes will be drilled in your board. So if you're going to export, you need to export the Gerber files as well as the drill file. Okay? And I made a note of that in the last part of the lab if anybody's interested. So what I would say is that you should do the design, and then if you're happy with it at the end, let me know, and we can talk about which manufacturer you want to use, and we can look up their standards for Gerber files and try and make sure that you can get an export that works with them. Okay? All right, so any questions about that? Yes?
Looking at the battery connector,
Yeah.
there's that line connecting them together. Is that not a rat line, or is that,
So
or does that just represent the fact that they're one component?
That's a good question. Let's see about that. They should definitely not be connected together. Let's see. So if I'm on layer 2 here, Those won't connect together. So that is an issue that I have to figure out. So I will look into that. In the meantime, why don't you guys start working on this, and I will let you know what's happening with the battery. Okay?
And if we try to keep this compact, how close can we get components together?
I think probably about 0.1 inches is probably okay, give or take. Yeah. Other questions? Okay. Then you guys are free to start working on this. If somebody could turn the light back on, that would be great. And I will take roll. You're also free to take a break in just a minute.